All right, well, it's 10 o'clock. Good morning, everybody. Welcome to our next installment of the Long Coffee Break series. My name is Jeff McBride, and I work in the Long VRV Equipment Design and Sales Group. Today, we will hear from Ed Mendieta, who is a Daikin Applications Engineer, and he will be presenting on VRV Acoustics, AHRI 260 sound data. We at Long have been working with numerous engineers in the last couple of years where sound has become a major design criteria, especially for K-12 schools looking to get CHIPS or LEED certification points. To our knowledge, Daikin is the only VRV, VRF manufacturer to provide testing related to AHRI 260 at this time. Without further ado, it is my pleasure to introduce Ed.
Good morning, everybody. Let's see, I'm gonna be the one that's gonna show you this presentation here and on AHRI 260 indoor ducted units. So thank you, Jeff, and welcome everybody again. So a key concept we need to cover leading into the AHRI 260 ducted unit data is to understand the difference with available sound pressure and sound power information. Sound pressure, for instance, will vary with the distance and direction from the source, as well as other environmental conditions, whereas sound power has nothing to do with environmental conditions. So to illustrate why something like the distance from source does not matter with power measurement, let's use a light bulb, and a 100-watt light bulb emits the same power constantly, no matter if it's 1 foot, 5 foot, or 100-foot distance away. Emitted watts don't change with distance. They stay in the source. Sound power is distance independent because of this, whereas sound pressure is dependent on distance. Lastly, both will change depending on equipment operating point. Anechoic chambers. Here's what an anechoic testing facility looks like. They're set up and designed to absorb reflections of sound. If you've ever had the opportunity to visit one of these facilities, these places are beyond quiet. They're super quiet. You can hear your heartbeat, you can hear your watch ticking, everything. They're pretty cool. Here we have our full line of VRV indoor units, including ducted and ductless units. The ducted units are further categorized into underceiling models, as you can see on the top, such as the FX-UQ 4-way cassette. There's in-ceiling models such as the FX-ZQ Vista 2x2 cassette and exposed floor standing FX-LQ models. Our ducted line covers low, medium, and high static units there on the left, from the top to bottom, which are the FX-DQ, FX-SQ, FX-MQ. There's also the multi-position FX-TQ air handling unit and concealed FX-LQ floor standing models. We'll describe the sound pressure data associated with ductless units first. Well, actually, we'll also go over a few tips for minimizing sound emissions from equipment too. We'll also have some comparative sound pressure ratings that I'll show you. Using our nav T-stat as an example, the user can vary the fan speed at the local controller, which in turn will affect sound levels at the indoor unit. Note that from a testing standpoint, the fan operates at the same point on each fan speed curve, regardless of application, without ductwork. Now, all the data obtained from ductless units is obtained from the anechoic chamber, where a specified position of the microphone is determined based on the type of the ductless unit. You can see here the positions of the microphone, whether it is ceiling suspended, ceiling cassette, wall mounted, or floor standing. You can see right here that each microphone has a different position relative to the indoor unit. The noise mitigation tip here is that it is recommended to maintain at least 1 foot of lift height for high lift drain pumps. Ductless sound data is obtained per JIS standards based on nominal testing conditions for common reference. These operations will vary based on installation conditions. Therefore, higher or lower decibel levels than published can be expected in the field. An A-weighted sound pressure is applied to microphone measurements, and this mimics the effects of human hearing. This accounts for the relative loudness perceived by the human ear. Sound pressure information is provided into octave band chart as well as A-weighted sound pressure and sound power. They can be found in Daikin's respective indoor unit engineering manuals. I'll provide examples of where to locate this information at the end of the presentation. Here's a nice graphic showing a comparison of A-weighted sound pressure for our ducted units, and I'm sorry, for our ductless units. The sound pressure varies depending on unit size. You'll see that the blue colored bars, which are the wall-mounted FX AQs, is the loudest ductless indoor unit across its range, whereas the gray colored bars, light colored gray bars, which are the FX FQs, is the quietest across its range. And an equivalent tabular summary of sound pressure comparisons. Again, the FX FQ shown on the leftmost column is the quietest at tested rating conditions. Another noise mitigation tip is that it is possible to set the indoor unit fan at low speed and then prohibit the changing of the setting in the service setting at the T-stat. Note that this will result in the capacity D rate of the indoor unit at the lower airflow rate. Now we'll describe sound pressure data and sound power data that is available for ducted units AHRI 260, plus some acoustical trends and comparative ratings. Ductless and ducted units have sound pressure data. The data is obtained through testing in the anechoic chamber. AHRI 260 sound power data is available for ducted units, and this data is obtained by testing in a different environment. This is called the reverberation chamber. The reverberation chamber testing environment will reflect sound. It diffuses the sound field within the chamber as opposed to the anechoic chamber, which absorbs reflections of sound. Just like the ductless units, ducted units have sound pressure data available according to JIS standards, which include location of microphone and A-weighted octave band sound pressure at each fan speed, as well as an A-weighted sound pressure and sound power at the bottom. AHRI 260 sound power ratings are important. Why? Because it establishes methods of testing and configurations for ducted units. AHRI 260 references AHRI 220, which establishes a minimum reverb room volume requirement. This is a good thing because smaller rooms create more opportunities for sound waves to bounce around and add up or cancel out, as you can see here on the upper left corner diagram. A bigger room equates to more accuracy, so the more thorough the standard, the more accurate the information. AHRI 260 sound power data is available for our FX-TQ air handlers, FX-MQ high static, FX-SQ medium static, and FX-DQ low static models. There are 3 reverberation room configurations for testing of inlet duct, ducted discharge, and casing radiated with free inlet for each model, with A-weighted sound power ratings for each size and model of unit. Here we have a sample of Daikin's fan characteristic curves, which describe the relationship between static pressure and air flow rates that can be found in our engineering manual, ESP on the y-axis and CFMs on the horizontal axis. Now, using the fan characteristic curve on the left, you can see that the AHRI 260 testing is taken from 3 data points. Then referring to table on the right, measurements are taken for each size of indoor unit, for each reverberation room configuration. You'll see here that the ducted discharge, ducted inlet, and casing radiated plus free inlet are the configurations. And for each speed, each fan speed, here we are showing high, which is HH, high and L fan speeds, and respective ESPs. The sound power level data and A-weighted sound power are listed to the right side of the table. Note that the external static pressure and the fan curves can be used to determine the approximate airflow rate for any particular test point. Here are some ducted unit sound level trends. Generally, the higher the ESP, the greater the sound level. The higher the user set fan speed, the greater the sound level. The ducted discharge sound component represents the highest sound level, as shown on that reverberation testing diagram. Another acoustical tendency or trend, if you want to call it, is that sound levels will be higher when operating to the left of the fan curve. You'll see that this matches with what I said in the last slide. In general, the higher the ESP, the greater the sound level. Here's a graphic comparison of A-weighted sound for our ducted units. You can see that sound power ratings vary depending on unit size. Going from left to right, the FXSQ, which is our medium static ducted unit, is the quietest at the 7 MBU level. Then FXTQ air handling units is the quietest at 9 and 12 MBU. At the 15 MBU level, the FXMQ high static is quieter than the medium static FXSQ. Then at 18 and 24 MBU, the FXDQ low static is quieter. The FXTQ is the only ducted unit available for 42 and 60 MBU sizes. Sound power levels are pretty even at 48 MBU level. And finally, the FXTQ is the quietest at 54. In general, the FXDQ low static is quieter than the same size medium and high static ducted units, with one exception at the 7 MBU level. Generally, the larger indoor capacity, the greater the sound level. However, cabinet opening size and fan operating speed can sometimes result in larger capacity units with a lower sound level. And this is the case if you look at the 15 MVH bar charts, where we see that a medium static model FXMQ that is quieter than the medium static FXSQ. In summary, for the ducted indoor units, sound levels of ducted indoor units depend highly on the operating conditions. To reduce sound levels, try minimizing operating static pressure. Generally, the larger the indoor unit capacity, the greater the sound level. Cabinet opening size and fan operating speed can sometimes result in larger capacity units with lower sound level. On the ductless indoor unit side, little variance in operating conditions. The FXFQ has the lowest sound levels of the ductless indoor units, and the noise mitigation tips, the possibility to limit fan speed and also maintain a greater than 1 foot lift on the drain pump. Here, we highlight the availability of AHRI 260 sound power data, in addition to sound pressure data for ducted units. AHRI 260 is a ducted only sound rating. It doesn't apply to ductless fan coils. All the ducted units, with the exception of the high capacity FXMQ MV, have had their sound data published. In Daikin City, the FXTQ sound pressure info is located in the FXTQ engineering manual, whereas the low, medium, and high static indoor units have AHRI 260 data published in separate supplemental engineering documents. There are currently no other units in development for additional sound data. However, I can say that AHRI 350 for indoor non-ducted units sound power is under consideration. So a big takeaway here is that you should consider evaluating specific operating points for both sound pressure and sound power to take advantage of AHRI 260 sound power data. All right, so let's take a look at where to find published AHRI 260 sound data and what the data looks like. So on the for the FXTQs, we do have a site which is called Daikin City. If you don't have access to it, you might want to try to get access to that. It provides you pretty much with all the documentation that we have on our VRV line. And so if we go on to Daikin City, and this is what it'll look like when we're looking at that particular model number, the FXTQ24 TAV-JUA. So if we type that in, this is what we get. And if you look at the very bottom of the related documents, you'll see the engineering manual, which is what I referred to earlier. This is where the information is going to be contained for the sound data. This is the front page of the document, excuse me. And then within that document, sound levels is a section within that document under sound levels. So this is what the information looks like for the FXTQ, to where it's given for a particular model number, FXTQ09. You'll see that for a ducted inlet reverberation room configuration, that we're given the 3 speeds across the 8-octave bands, and you're given information an NC, or which is noise criteria. And the noise criteria specifies the maximum noise levels that can be present in each octave. And this is what it looks like for that particular reverberation room configuration. And then there's one for the same model for ducted discharge. And then you have the same data, which is presented for the casing radiated reverberation case. And then that'll just repeat itself for every larger size or different size of FXTQ. So if we go over to the ducted or the FXMQ, FXSQ, and FXDQs, when we go into Daikin City, look down there on the related documents, you're going to see that there are two engineering manuals. One of them has AHRI in there. So this is a supplemental data sheet. That's what it's referred to, supplemental. And so the information will be contained here for those units as well. It does give a little blurb on, the reverberation configurations from which the sound power ratings are obtained. And this is what it looks like. Now you'll see that the information looks different, but it's the same. This is in tabular format. So pretty much all those points you see on the left for the FXTQ are contained in tabular format. As I had showed earlier, you have different octave band sound power level measurements and a single A-weighted sound power for each configuration, reverberation room configuration, each fan speed, each ESP, and that's what the information looks like. With a few notes on the bottom, which shows that some corrections were put into those numbers. All right, so this concludes my presentation. I thank you for taking the time to attend, and let me hand it back to Jeff.
Please join us next week for Operating Room Air Control Systems, hosted by Jeff Rodell, who's with Long, and Julia Lewis with Kruger. And thanks very much, everybody, and enjoy the rest of your Thursday.